Hey everybody, this is Virtual Mr. B. Today we're going to be talking about the fundamental counting principle and permutations and combinations. So let's start with this scenario. Let's say you have 4 sweaters and 2 pairs of pants. How many different sweater pants outfits can you make? So let's figure this out. Let's map every sweater to the corresponding pair of pants. And we can count them up, and we could see that we would have 8 possibilities. Well, how do we get that? We did 4 sweaters times the 2 pair of pants, and that would give us 8 possibilities. So this is called the fundamental counting principle. If you have n choices for a first item and m choices for a second task, then you have n times m total possible choices. So I'm going to have you guys try one. If an ice cream store offers 20 different flavors and 3 types of cones, how many different ice cream cones can you make? Take a minute and try the problem, and pause the video, and then come back and see the answer. So we'd have 20 choices for the ice cream times 3 cones, which would give us 60 possible choices. We're now going to talk about something called factorials. So in math, if we write an exclamation point after a number, like 4 factorial, that doesn't mean that we're just really excited, right? It's not just 4, okay? What it really means is this. Well, first we pronounce this as 4 factorial, okay? And what that means is we're going to do 4 times 3 times 2 times 1, which is just 24. So with 5 factorial, we would do 5 times 4 times 3 times 2 times 1, which would just be 120. So to get the idea, we take the number that we start with and multiply it by every single number that came before it. In math, we also have something called 0 factorial, and we're just going to define that to equal 1. So let's do a little practice with these. Let's say we have 6 factorial. Okay, take a moment and try it. Pause the video. So we'd have 6 times 5 times 4 times 3 times 2 times 1. Okay? And we could work out what that number would be using a calculator. Let's say we have the next one, 4 factorial times 3 factorial. Okay? Now, one thing right away, this is not 12 factorial, so beware. We have to perform each piece separately. Okay, so this would be what? 24 times 6. Okay, and 24 times 6, what is that? 4, carry the 2, 6, 12, 144. Okay. Finally, we have 10 factorial over 8 factorial. So I'm going to do a little trick here. We don't want to calculate 10 factorial by hand, but I'm just going to write out what it is. Over 8 times 7 times 6 times 5 times 4, 3 times 2 times 1. And we're going to cross out everything that we can, and you see what we're left with, 10 times 9, which is 90. Now we're going to talk about a permutation in math. And a permutation is an arrangement of objects where the order matters, okay? The order matters with permutations. In other words, ABC is different from CBA. Okay, so let's think of some examples of permutations. Okay, license plates, the order of the numbers and letters matter. People standing in line, phone numbers, delivery routes, passwords. baseball lineups. All these things are where the order matters. In other words, they're all permutations. A combination, on the other hand, in math, is an arrangement where the order does not matter. In other words, ABC is not different from CBA. Those are the same combination. Let's brainstorm some of those. So pizza toppings, okay? So if I order a pepperoni mushroom olive pizza, okay, and the person next to me orders an olive mushroom pepperoni pizza, those are the same pizzas, the same orders. So the order did not matter for those. Lottery numbers, okay? I know in the Super Lotto, it doesn't matter what order you get the numbers in, as long as you get them correct. Okay, the list of friends in your Facebook account, okay? They're all still your friends, okay? They're not ranked in a certain order. And adding ingredients to a blender, okay? We're going to throw everything in, and out comes the final product. Books on a shelf. Okay, so this one's up for debate, but if I just throw books on a shelf, it's one group of books. The order doesn't necessarily matter unless you are trying to alphabetize them or put them in an arrangement like in the library. Okay, so what I'm going to have you guys do is a fundamental counting principle, permutation and combination, sorting activity. Okay, so you're going to get the handout from the sub. And with your team, you're going to read through the scenarios and you're going to decide, are these permutations, combinations, or fundamental counting principle scenarios? Let's take a look at the first one together. 4 cars enter a race. How many ways can the cars come in first, second, third, and fourth place? Okay. Does the order matter of the outcome? Well, yes, because we have first, second, third, and fourth place. So this is going to be a permutation problem. Let's see the second one. The car you're thinking of comes in 9 colors and 3 different styles. How many ways can you order the car? Well, what we're going to have is we're going to have 9 ways times 3, which is 27 possibilities. So this is a fundamental counting principle problem. I'll just write F for that. Okay, so go ahead and work through the rest with your neighbors, and then pause the video and check back the solutions in a minute. Note on this one that we're talking about the ways that the songs can be arranged. So that's an order. So the order of the songs matters. That's a permutation. Here's a permutation also, because we're looking for specific roles out of the group of 30 students.